From the accompanying graph of y equals f of x, A, find f of negative 2, f of negative 1, f of 0, and f of 1. For part B, find two values of x for which f of x is equal to negative 3. And finally, in part C, estimate the range of f. Assume that the arms of the graph extend upward indefinitely. Well, in order to answer parts A and B, we need to understand function notation. When we see y is equal to f of x, we want to recognize that f is the name of the function, x is the input, and y is the output. So for part A, when we're asked to find f of negative 2, what we're really looking for is the output when the input is negative 2. For f of negative 1, we're looking for the output when the input is negative 1. So on our graph, the first thing that we'll do is locate the input axis, which is our x-axis, and we'll find the numbers negative 2, negative 1, 0, and 1. So first of all, we see we'll find negative 2, and we'll go vertically up until we intersect the graph of the function, and we're going to label that point. It has an x and a y coordinate. Put the x coordinate in blue and the y coordinate in red. The x coordinate is negative 2 and the y coordinate is 5. And I'll go ahead and do that similarly for x is negative 1, 0, and 1. Now that we've labeled the points, we can go ahead and find the function values. F of negative 2 is equal to 5 because 5 is the output when the input is negative 2. F of negative 1 is equal to 0 because 0 is the output when x is equal to negative 1. F of 0 is equal to negative 3 and f of 1 is equal to negative 4. Part B is a little bit different. We're given that f of x is equal to negative 3, and we're trying to define the two values of x that produce an output of negative 3. So instead of locating negative 3 on the x-axis, what we'll do is locate negative 3 on the y-axis, and we'll look horizontally across and find where that intersects the graph. So here's negative 3 on the y-axis. There's one point on the graph of the function here, but if we look horizontally across, we see that there's a second point. And the coordinates of this point are 2 and negative 3. So notice that we've got two ordered pairs that have negative 3 as the output. The corresponding x values are 0 and 2. So f of x is equal to negative 3 when x is equal to 0, or x is equal to 2. Finally, in part C, we're asked to determine the range of the function. The range is the collection of all the output values of the function. So what I'd like to do is to imagine taking a horizontal line. I'll grab the horizontal line here and start at the bottom of the graph. At negative 5, if we look horizontally across, the horizontal line does not intersect the graph. That means that there's no output that produces negative 5. As we slide the horizontal line up, we see that the first place that it intersects the graph is at negative 4. When x is equal to 1, the y value is negative 4. So negative 4 is in the range of the function. Similarly, negative 3 is in the range, negative 2.5, negative 2. As we slide the horizontal line up, we see that it continues to intersect the graph, and we're given that the arms of the graph extend upward indefinitely, and so this horizontal line is going to continue to intersect the graph forever and ever as the y values increase without boundary. So what is the range of our function? Well, it's a collection of y values. So I'm going to put the range is the set. So the range is the set of y values such that those y values are greater than or equal to -4. We can also write the range using interval notation. The first number in the range as we go from bottom to top is -4, and we want to include that, so we use a bracket, write down the number -4, and then the y values increase indefinitely without bound, and so we use the infinity symbol, and infinity is not a number. The range just continues on indefinitely, and so we use a parenthesis. So the range is the interval from -4 to infinity, or the set of y's such that y is greater than or equal to -4.